Hello everyone, my name is Krishnakant Chaube and I am going to discuss about Ohm's law. And under that we will discuss in this way. The first is the electric circuit and current. Second is the Ohm's law and its limitation. And third is the resistance and factors on which it depends. And fourth, we will discuss about the different combination of the resistance to find the equivalent resistance of a given circuit. So one by one we will discuss. The first topic is electric circuit and current. So first we will discuss about electric circuit. What is electric circuit? It is the connection of electrical component. It is the connection of electrical component in a way so that it will be able to flow the current through that connection. Suppose if we want to make a circuit, this is the resistance. After that we can connect a ammeter and one source, that is battery. Because it is a closed path, to flow the current we need a closed path, through that the current can flow. So this is the resistance, this is the ammeter to measure the current which is flowing through the circuit, and this is battery. These are the essential components to make a circuit. And the second is the current. What is current? Current is the rate of flow of electric charges. The electric charges which flowing with the time, that is called the current. So the basic block is the battery, second one is the resistance, and another is the ammeter. To measure the voltage across the resistance, we can connect the voltmeter which is connected parallelly to the electrical component, that is resistance. So this is the electric circuit. And here electric circuit, suppose whenever we are talking about the flowing of current through the circuit, we need to understand about why current flow and from where current flow. So suppose I would like to take one example, the water which flows from a more height to the less height, that means we need a height gradient to flow the water. That in the similar way, suppose the wind is flowing, so it will flow from the more pressure area to the less pressure area. That means to flow the wind we need to have the pressure gradient. In the similar way, to flow the current we need to have what? Voltage gradient. That means a current can flow from the higher voltage to lower voltage, and this voltage gradient will be provided by this battery. The one terminal of the battery, that is called a node, will have the higher potential than the other terminal of the battery. That means it is providing a voltage gradient. That's why the electric charge will get the flow or movement, and it will flow through the circuit. Second one is what? Second one is the based on conservation of energy. That means we are getting the voltage gradient by converting the chemical energy to electrical energy. As we know from the conservation of law of energy, energy neither be created nor destroyed. It can be converted from one form to the another form. So what is happening here? The electric potential energy at the anode side is given by this battery. The charges which is present at the positive side of this battery will be at more electric potential energy, and at the cathode side it will have the less potential energy. So firstly, this battery is giving the chemical energy. Through the battery, the chemical energy is converted into the potential energy, and it will be responsible to give the movement to the electric charges. And once it will get the electric charges start flowing, and the flow or movement, the rate of flow of the electric charges, we get the current, and or we know the current of the flow of rate of that electric charges. And while flowing this electric charges, I mean current through the circuit, we are going to get some energy. While passing through this resistant, it will get converted into some other energy form, that is called heat. Means first we had the chemical energy, is going to convert into the electric potential energy. Potential energy. And again electric potential energy is going to convert into the heat energy. So we'll discuss later more about this one, but the second topic is the Ohm's law. Basically we had started the Ohm's law to understand. Before that we need to understand the electric circuit. That's why we had explained this. Pause it.
Start.
Second topic is the Ohm's law, which was our motive to explain. It is the basic fundamental law for current electricity, and which gives the relation between voltage which we have applied across the circuit, and because of that the current which is flowing through the circuit. Means according to the Ohm's law, the voltage is directly proportional to the current which is flowing through the circuit. If we will remove the proportionality constant, we are going to get R, and that is called the proportionality constant. Constant or resistance. Means at constant temperature, if you are going to apply V voltage, V amount of voltage to a circuit, it will constitute to flow the I current through that surface. That relation gives by the Ohm's law. This I. So we'll be able to calculate. If you know any two quantities, suppose voltage if you know and current we know, we will be able to understand or we will be able to calculate this proportionality constant, that is resistance. Or other form also, if you know I and R, we will be able to calculate the voltage. So Ohm's law, according to Ohm's law, at constant temperature, temperature should be constant. At constant temperature, if you are going to get the relation between voltage and current, we will be able to calculate it. But it also have some limitations. So we would like to discuss about the limitations of Ohm's law. The first limitation of the Ohm's law is it does not hold good for the unilateral network. So first is the it does not hold good for unilateral network. And what is unilateral network? We need to discuss it. Unilateral network means if it is a I and V graph, if you would like to draw, then for the different direction flow of current, the voltage and current relationship for the different direction of flow of current is not same. Suppose if in this direction it has the flow of current, this other direction it will have some other. So this kind of, for this kind of networks, it is not able to give the relationship between voltage and current. Here it fails. Second, it does not able to give the relationship between the voltage and current for the non-linear elements. Non-linear elements means, second one is the, it does not give for non-linear network, non-linear element. Like suppose if you are going to talk about the diode and transistor, non-linear element means if you are increasing voltage in linearly, then our current should also increase linearly. And this kind of behavior is not followed by some of the electrical component or electrical networks. One of the electrical component example of it is non-linear element is diode, second is the transistor, and so on. So for this kind of electrical component, we won't be able to get the voltage and current relationship by using the Ohm's law. So these two are the limitations for that. And the next topic is resistance, which was the proportionality constant. Resistance means which resists to flow the current, which resists the flow of current is called resistance. It is a property of material. For different materials, some material has the more resistance, some material has the less resistance. If a material will have the more resistance, that means if we are going to calculate, we have applied some voltage V and that material has the more resistance, then we are going to get, if it will be more, then we are going to get less current. That means if a material which have the more resistance, we are going to get less current. If it will have the less resistance, we are going to more current. That means current flowing through the circuit will be inversely proportional to the resistance property or resistivity of that material, inversely proportional to the resistivity of material. Means resistance demote the flow of current. No? So from that we can tell resistance demote the flow of current or resist in flowing the charges through that material. If we will talk about resistance, it depends on the three quantities, that is rho, L upon A. Rho is the resistivity of the material or the conductor, resistivity of the conductor, L is the length of the conductor, L is the length of the conductor, and A is the area of cross section. A is the area of cross section. So if you consider a conductor, this is the area of cross section through which area of the cross section through which the electric charges are going to flow. This is the length, and every conductor or every material has the property which is defined by this resistivity. So R resistance directly proportional to the resistivity, and it is also directly proportional to the length of this material, and it is inversely proportional to the cross section. That means if resistivity will be more, that material will have the more resistance, and that means more it will resist in flowing the electric charge through it. If the length will be more, we are going to get more resistance, and if area of cross section will be more, we are going to get less resistance, and vice versa. We can understand the resistive property of any conductor. Okay, and so the resistance depend on the resistivity, length of the conductor, and area of cross section through which the electric charges are flowing. And one more factor on which resistance depends, it is the temperature. For the conductor, because we are talking about the conductor only here, for the conductor, as temperature increases, the resistance of that material is going to increase. So that can be calculated with the help of, if R of t is equal to R naught into 1 plus alpha del t. With the help of this formula, we are going to calculate where alpha is the positive for a conductor. And R naught is the resistance provided by that material at temperature T equal to 0 Kelvin. Resistance at temperature T equal to 0 Kelvin. This is the resistance which we can calculate by using this formula. Resistance at temperature T equal to T Kelvin. Temperature T Kelvin. So suppose if we have a resistance, suppose I am considering one example. We have the resistance R naught 20 ohm, because unit of the resistance is ohm, and unit of resistivity, which I discussed earlier, is ohm per meter or per centimeter. This. So if we are trying to calculate this resistance at, if R naught is 20 ohm, that means resistance at T equal to 0 Kelvin 20 ohm. So what will be the resistance? At T equal to 40 Kelvin. And suppose for calculation of this problem, we are taking alpha equal to 0.01 per Kelvin. So if we put this all thing in this one, we will be able to calculate R T equal to 40 Kelvin. R naught is the 20 ohm. 1 plus this is 0.01 Kelvin multiplied by the change in temperature is what? Change in temperature del T will be T2 minus T1. So T2 is 40 Kelvin and we have the resistance at 0 Kelvin. So we are going to get 40. Del T is the 40 Kelvin. So if you put in that formula, if you put in this formula, we are going to get resistance at that temperature. This is 20. 1 plus alpha is 0.01. We can put here also. So 20, 1 plus 0.01 multiplied by 40. 20, 1 plus, it will be what? 1 by 100 multiplied by 40. So 4 cancel, 0.4. We are going to get 28 ohm. So a material which has the resistance at T equal to 0, 20 ohm will facilitate or will provide the resistance at T equal to 40 Kelvin, 28 ohm. So this variation we can also understand, or we can also consider in the problem. And the next is, we will try to find the equivalent resistance for different kind of combinations.
Start.
The last topic is the calculate equivalent resistance. Calculate equivalent resistance for given network, given circuit or network. So first is the series combination. Series combination. Second is the parallel. We will try to analyze parallelly. Second is the parallel combination. So in series combination, when a resistance is connected in this fashion, I am taking the three resistances, we will generalize it. So what will be the equivalent resistance provided by this combination? We will try to calculate it. Suppose, to understand this, I have applied a one voltage V. Voltage V, that is, I have connected a battery which is providing the phi amount of potential gradient. So one thing, in the series combination, the current will flow through all these resistance same. The I same current will flow through the R1, R2 and R3. So, and it is having the V1 amount of voltage is dropped across this resistance. In the similar way, I am taking V2 amount of voltage drop across R2. And this is V3 amount of voltage drop across R2. So we will be able to write V equal to V1 plus V2 plus V3. Okay? So in the similar way, we will be able to write V equal to the I current which are going to flow through it into the R equivalent. This is the equivalent resistance which we can replace in place of all these resistances. And in the similar way, same current is flowing through all the resistances. So R1 into I into R2, according to the Ohm's law. We know that Ohm's law, V equal to I into R. So in place of that one, we are replacing. In place of V1, I am replacing I into R1 because R1 resistance is there, plus I into R3. So from that one, if you calculate, I is going to cancel. We are going to get R equivalent equal to R1 plus R2 plus R3. So in this way, we will be able to calculate. If this kind of fashion, this kind of connection will be given, we will be directly able to write, or directly we will be able to replace this all three combinations with a single resistance, and its value will be R1 plus R2 plus R3. In the similar way, for the second case, if the combination is connected in this way, this is R1, this is R2 and this is R3. We can see it is connected parallelly. No? So to calculate the equivalent resistance of this kind of connection, how we will be able to calculate, we will see. So one thing we will have to remember, here in the series combination, the same current is flowing these all three resistances, but voltages are different, which is dropped across each resistances. That means current will be same and the voltage will be different for these resistances. Here what will happen? The voltage across all these resistances will be same, but the current will be different. So if I amount of current is coming from the battery, then it will be divided into some. I am taking the I1, this is I2, this is I3, and we can tell here I, the main current which is coming from the battery, will be equal to the I1 plus I2 plus I3, and voltage across all the resistance, across R1 also V amount of voltage will be there, across R2 also V amount of voltage will be there. In the similar way, across R3 it will be V amount of voltage will be there. So if you want to write I in terms of according to Ohm's law, we can write I into R equivalent. So if I am trying to write in place of I, we can write V upon R equivalent. So this will be V upon R equivalent. In the similar way we can have, because across every resistance the same amount of voltage is there. So V upon R1, this is V upon R2, this is V upon R3. So if you calculate the V, I would like to write here. This I am going to write here. So we will be able to write 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. So from that we will be able to calculate it, and one example we will take and we will try to explain it. So example, first I would like to derive one thing. If it is V and this one is R1, R2, and here V and R1, R2 is known, so how will we be able to calculate V1? It's our motive. So V1 equal to V into R1 upon R1 plus R2. In the similar way we will be able to write V2 equal to, how it has come I will tell. This is V2 equal to V into R2 upon R1 plus R2. So we can remember this and directly we can use in the examples. How it has come? Because I we can get V upon R equivalent, which we have calculated already. So here R equivalent will be what? It will be R1 plus R2. So V upon R1 plus R2, and we will have to calculate the V1. So V1 equal to what? It will be I into R1, and I is there V upon R1 plus R2. So we can replace here V into R1 upon R1 plus R2, which we have got R1, which already I have written here. And in the similar way we will be able to get V2. So one example if we will take, this is the V5 volt battery we have connected, and this is 2 ohm and this is some 8 ohm. So what will be the voltage across this 2 ohm resistance and what will be the voltage across this 8 ohm resistance? So V1 equal to, directly we will be able to calculate by using that formula, that is 5 upon multiplied by 2 divided by 2 plus 8. So how much we are going to get? 10 upon 10. That means 1 volt. In the similar way, if you would like to calculate the voltage across 8 ohm, this is V, already we have written in the formula. This is R2, 8 ohm, and this is R1 plus R2. So we are going to get how much? 0.4 divided by, this is 40 divided by 10. So we are going to get 4 volt. That means out of this 5 volt which we have applied through this circuit, the 1 volt is going to be appear across this 2 ohm resistance, and other 4 volt is going to appear across 8 ohm resistance. That means if resistance will be more in the series combination, we are going to get the more voltage across it. If resistance will be less in the series combination, we are going to get the less resistance. So that is the conclusion we can draw from this series combination.